So 1.3 day 2, we're looking at modeling with linear functions, but now we're looking at specifically line of fit. So data do not always show an exact relationship. So in our previous lesson, we did see ones where they were linear, they lined up perfectly. Now that doesn't always happen. So when the data in a scatterplot show an approximate linear relationship, you can model the data with a line of fit. So here's how we would do that. First, we would create a scatter plot of the data, and basically you just take all the points and graph it on a coordinate plane. Then we're going to sketch the line that most closely appears to follow the trend given by the data points. So there should be about as many points above as there are below it. Now we're going to choose 2 points on the line and estimate the coordinates of each point. Now these points do not have to be the original data points, but they could be. So you'll see later on what that looks like. Then we're going to write an equation of the line that passes through the 2 points from step 3. So we'll use our find the slope and then use point slope to find the equation. Now this equation is a model for the data. So let's find a line of fit. The table shows the femur lengths in centimeters and heights of centimeters of several people. Does the data show linear relationship? And if so, write an equation of a line of fit and use it to estimate the height of a person whose femur is 35 centimeters long. So first, we're going to create a scatter plot. So it is good to look at what is the lowest number we have here and what's the highest, and same thing here. So what's our range to kind of help us out with the graphs. Now to kind of help you out, I'm going to break the graph here, and I'm going to start at 30 and then skip 1 to 40 and then 50 right here. And then on the y-axis, I'm just going to go 140, 150, and so forth. Go by tens. And 200. The lowest value I have here is on the right is 141, right? So that's the lowest here. And the lowest here I have 30, and it goes to 50. The highest on here is about 195. So that kind of helps me out with the graph. Now we're just going to plot these points. So let me start us off. So we have 40 and 170. So first of all, the x is our femur length. So it's good to label your x and y axis. And then the height is our y value. Okay, and these are all in centimeters. Now 40 and 170. So 40 and 170, and now that's actually perfect, right? So that's kind of nice to have to plot, is right here. And I took care of that. Next is 45 and 183. So maybe about right here. And so please continue to graph the rest of these points. I'm going to pause the video, and you finish graphing them as well. Pause the video and try it out. So hopefully you graphed all of these points. And so does it show a linear relationship? And it does, right? So it's all grouped together. It's all moving in a positive slope. An example of something that's not moving together, so just to kind of on the left side here, that wouldn't be moving in the same direction as if you have something like this, where there's no relationship, right? There, you can't tell that there's anything that corresponds. And then you have something that could be something like this as well. So that does make kind of a linear relationship as well, right? This is negative, there's no relationship, and then we have this one, which is positive. So now we want to draw a line, right? So looking at our direction, sketch a line that most closely appears to follow the trend. We need to try to make as many points above and below it. So here's the number line that I came up with. And so I have some points that are below, and I have some points that are above, and it passes through a lot of these points here. Now let's pick 2 points. Now they don't have to necessarily be original points, but they could be. And so in this case, I see this point here. I'm going to use that one. This is 40 and 170. And then that one's pretty close right up here. So I'm going to use 50 and 190. This is 195. So I'm going to label this as x2, y2, and x1, y1. And so now let's find slope. So slope is going to be the y2, so 195 minus the y1 of 170 over 50 minus 40. So this ends up being 25 over 10, or that's going to be 5 over 2, or that's approximately 2.5. So slope is approximately 2.5. Now we need to find the y-intercept. So let's use the point slope formula. And then, so my slope I already know is 2.5. I'm going to use the point 40 and 170 as my x1, y1. So this is y minus, our y1 is 170 equals a slope of 2.5 times x minus x sub 1, which is 40. You could use any point that you want on the line that you created, like you could use this one here, and that one's fine. So any of the 2 points, you'll get the same exact formula. I just chose that one because they're smaller numbers. Now let's go ahead and write this in slope-intercept form. So then we distribute the right. So 2.5x. And then 2.5 times negative 40, that is going to be negative 100. Then we're going to add 170 to both sides. So we find the equation is y equals 2.5x plus 70. So here is the equation of the line that we can use. Now next, we want to estimate the height of a person whose femur is 35 centimeters long. So it's telling us 35, so that's actually our x value. Oh, I wrote y there, our x value. Our x value is 35 centimeters long. So we're going to plug in 35 into here to find out what the height y is. So let's plug it in. Y equals 2.5 times 35 and then plus 70. So that is going to be 87.5 plus 70, or the approximate height is about 157.5 centimeters. So we can say the height of a person whose femur is 35 centimeters is about 157.5 centimeters tall. So now, just to kind of talk about it a little bit, is that we can actually use a graphing tool to help us find the line, the equation. So the line of best fit is a line that lies as close as possible to all the data points. So it's as close as possible to all the data points. Many technology tools have a linear regression feature that you can use to find the line of best fit for a set of data. Now, we're going to use a graphing calculator, or in this case, let's use Desmos. We're going to use a linear regression feature on a graphing calculator to find an equation of the line of best fit for the data in example 3. Estimate the height of a person whose femur is 35 centimeters long. Compare the height to your estimate in example 3. So to kind of help you out with Desmos here, I do have a separate video on that, so you can watch that as well. But let me go through some screenshots to hopefully help you out. So when you do this, when you go to desmos.com, and hopefully you are familiar with that, just go ahead and type desmos.com and you'll be in this open graphing area. Now what you'll do next is, because we need to type in a table, and so what you're going to do is click on this plus button, and then when you click on that plus button, you're going to see this drop down menu here. And then so what you want is a table. So click on the table, and then so here is a table, and you can type in all of those data points. And so you're going to type in all the data points from here, right? So type in all of these values in here into Desmos. So go ahead and try that out. Then this is what it should look like. Now what you also need to do after you plug in all of those points, just double check them, make sure they're the right numbers because that'll help you out, is you'll want to zoom out so you can find your points, because you'll be homed in the 0, 0 at the origin, and so zoom out by pressing this minus button and you'll find your points, and so then you'll want to get to that. So once you see that, next what you'll want to do is you're going to type in this equation. It is y sub 1, and this is a tilde, mx sub 1 plus b. Now there is a keyboard option here and you have to find it. It might be a little easier to do on your computer, but it is still possible to do it on a smart device. So I just did it on my iPad. You just have to search for the sub values and so forth, but you could type it in. what's really cool about this is it gives you this line, and it draws a line for you, this best line of fit. And so that is what's right here. It did it on the computer. And then looking at this, it gives us the slope and the y-intercept. So there is our equation. Y equals our slope of 2.60357x plus the y-intercept of 64.9968. Now, what's really cool about that is if we go back, it's pretty close to our own, right? It's 2.5 plus 70. That's really close, so very cool there. Then what you do to find the height of a person at 35, we're going to make x equals 35, so type that out. That's probably the fastest way to do that. And when you do that, you notice that you'll get a vertical line at 35, and you find that the height is 156.122. That's really close to our answer of 157.5. So again, very, very cool that you doing it by hand, we do get very, very close to the answer that's generated on Desmos using the linear regression tool. Now, I do want you to try one on your own, so try this example here. So you're going to have to do it by hand first of all, so just kind of good practice, and then use a linear regression feature on the graphing calculator to see if you can get the answer. So here it is. This is my calculation work. Now, it could be a little different, right, depending on how you drew your dots, what equation you got. But this is how you would do it. You find the slope, do the same thing that we did before, find the y-intercept, write your equation, and then plug it into Desmos. Here's just my shorthand writing of what to do. So kind of what I went over earlier about clicking the plus in Desmos, then the table, type in all the points, find the points on the graph by zooming out, type in the equation here, and then you can trace, or you can type in x equals. So in this case, it's x equals 35, and our height was 156.122. And you do the same thing with here. Okay, so I hope this helps you out.